So let's actually let's plot W versus W max. So the x-axis would be W. Let's grid it. The left is W, and the y-axis is W max. So does W ever exceed W max? I think so, because at this point, right, W is actually greater than W max. So why is this array? Wait, oh, there is actually one over here, right? So okay, so the limiter is actually active at one point, which is probably over here. Okay, so let's see what's the index of that value. Find W greater than W max, 52. So W 52, W max 52. Okay, so W max is actually smaller. Now this should actually set a value, right? So let's step, and if we if we plot this again, yeah, this value should no longer be there. Right, the value is actually truncated, right? So if you compare to the previous plot, yeah, I think the value is no longer there, and W less than W min is equal to this. So let's plot again. Okay, so here we should actually get this point truncated, and if we step on this, yeah, this is doing the right thing. Okay. That's interesting. So I must have some bug somewhere. So let's actually continue, and I'll tell you after the class what's actually going on. Continue. Interesting. This is still there. What could be wrong? Okay, so let's discuss this next lecture after I figure this out. Okay, so the total variation diminishing scheme is supposed to remove these oscillations. Basically, if the solution has a local maximum of 1, the local maximum should never exceed 1. So what we have been seeing shouldn't happen if I implemented this total variation diminishing scheme correctly. All right. Okay, so this is basically supposed to get us a second order scheme with that still can resolve shock waves correctly.